Welcome back. Before we start, I just want to say I believe you will get the most effective practice if you put away your notes and calculator when you work on the multiple choice questions in this video. So if you don't feel ready yet, you may wish to pause the video and review kinematics a little bit before continuing. Are you ready? Okay, so here we have a projectile motion. The projectile is shot at an angle, so we have to find its components. To find the horizontal and vertical components, remember we have to make this rectangle. We use the parallelogram method. Our parallelogram in this case happens to be a rectangle. So this will be the vertical component, that's the horizontal component. And we have to separate the horizontal and the vertical side. The horizontal initial velocity is adjacent to the angle, so it is the cosine component. The vertical side is the same as the opposite side, so it's the sine component. Of course, you know, if you figure out one is cosine, then the other one must be sine. Now, if you really spend the time to figure out every single one of those, it can take a long time. So you may or may not have to go through all the trouble. So let's look at it. Part A, well, that's going to take a long time to find out. So we're going to wait on that. For part B, well, to find the maximum height, that can take a while too. But in this case, you happen to not have to take a long time because the maximum height depends on the vertical motion. And the vertical initial velocity is the sine component. That means your answer should not have cosine, but not sine. So B has to be wrong. C. You want the speed right before it hits the ground. Now, right before it hits the ground, the speed is not 0. In fact, we know that it's a symmetric case, so if it's shot at a speed VO, it's going to land at the same speed that angle theta below the horizontal. So part C is definitely wrong. And then part D, let's see. The velocity at the maximum height is that. Is it right? Now let's see, a lot of people may say, oh, at the maximum height the velocity is 0, but the velocity at the maximum height is 0 only on the vertical side because the object goes up and then down. At the maximum height, it is a turning point for the vertical direction. But on the horizontal side, it's constant velocity motion. This initial velocity never changes. Because if you look at this horizontal motion, there's no turning at all. So there's no turning point for the horizontal side. So at the maximum height, the vertical velocity is 0, but the horizontal velocity is still there. So D is right. So of course, once you find the right one, you don't really have to continue. But let's just take a look at the E. The acceleration at the maximum height is not 0 because it's up in the air, so it still has this acceleration, that is the gravitational acceleration, the downward one. Now, we don't really have to go through the trouble for A, but the correct answer is there is a 2 over there. In this question, we want to find the direction of the object's average acceleration. Do you remember what an average acceleration is? That is, by definition, the change in velocity divided by the change in time. Now, since the change in time is going to be a positive number, that means the acceleration, the average acceleration and delta V, they must carry the same sign. That means the same direction. So if I want the average acceleration's direction, I just have to find the delta V's direction. So let's find out the direction for delta V. The change in velocity is the final minus the initial. The final velocity goes to the left and it's longer, and the initial velocity goes down but shorter. How do we subtract vectors? Subtracting vectors would be like adding the vector in the opposite direction. And then I can add these two vectors, tail to tip. I put the tail at the tip of this arrow. The sum is this vector. It starts here and there. So it's that direction. So the answer is E.